Hey guys, I'm preparing this video the night before for you guys just in case. I won't be there tomorrow. I might be and I may not. It all depends. My son might be sick, so we're taking a look at it in case I'm not there. I want to make sure that I keep up on the lesson for you. This is lesson 4.20 and negative exponents. So we're going to talk about what happens when an exponent is 0 and what happens when we have a negative exponent. Actually, we've done all these already. They are not anything new. They're things that we've talked about already. We already know that when we take anything, well, I should say, let me change this from anything, almost anything, and we raise it to the 0 power, it's going to equal 1. So if we get 1 to the 0 power, that is equal to 1. If we get 2 to the 0 power, that is equal to 1. 3 to the 0 power, that is equal to 1. The only one that we cannot use is that 0 to the 0 power. That's one that we can't do. That one is actually undefined because it involves dividing by 0 in the long run. When we do the long explanation for it, just understand that in the case of when we're raising things to the 0 power, that base cannot be 0. That's the only thing it can't be. Anything else raised to the 0 power will be 1. Just something to remember, and we're going to use that today. Additionally is that when we've got negative exponents, the way that you can think about them is they're basically on the wrong side of a fraction. So what we've got here is that if we have a to the negative n, if we look at it just like that, it looks like we could write this as a fraction. So we write it over 1. And when we have a negative exponent, we can fix it. We can rewrite the whole thing by just moving it to the other side of the fraction. Now, if there is no fraction, it just means put it in the denominator. So what I'm going to do is put a to the n in the denominator. Now, notice when it changed, when it moved to the other side, it was up top all by itself. So in the beginning, it kind of looked like this without a fraction there. And when I move it to the denominator, it loses that negative. So we would just rewrite it just like this. So when we look at things, you're going to see that every single time that we've got something raised to a negative exponent, it's going to move it to the denominator. There's one exception. If that negative is in the denominator, like let's say that we've got something that's negative in the denominator, for example, like let's say we've got 1 over 3 to the negative 2 power. Really, that's the same thing as what it means is that this is on the wrong side of a fraction. So we're just going to move it to the right side of the fraction, like the top of it, and it loses its negative again. So now notice it's moved to the other side of the fraction. It's lost its negative, just like we did when we moved it to the bottom of the fraction. So 3 squared would just be 9 over 1, which is just 9. So we're going to work with those ideas here and go through some of the samples. So let's start with A. And this is how you're going to have to write it out in your homework as well. So we've got 10 to the negative second power. We're going to start by rewriting this as 1 over 10 to the second power. Reason being because that negative 2 right there, that since it's a negative exponent, it's going to move it to the denominator. If there isn't a fraction there, it just moves it to the denominator. We get 1 over 10 squared. Now there's something we can do with that. That just becomes 1 over 100. Again, because it has a negative exponent, we moved it to the denominator. If it were already in a fraction, like if it was already in the denominator, we would just move it to the numerator. So let's try another one. Let's look at B here. Now notice that this is kind of an interesting one. We've got a negative 3 and a c being raised to the negative second power. Now, it's very important to notice the difference between this and ones we're going to see in a minute. In this one, it is only c that is being raised to the negative second power. And I know that because there's not a parentheses around both the negative 3 and the c. I'm not going to draw that in because it doesn't exist here, but I'll show you in another example. It's only the c that negative 2 goes with. So there's a negative 3. Now, nothing's going to happen with that negative 3. It's going to stay a negative 3. Because that negative 3 doesn't have an exponent on it. However, the c has a negative 2 as an exponent. So what that means is that c is going to move to the denominator. It's still going to keep that 2 as an exponent, but it's no longer going to be negative because I moved it to the other side of the fraction. So we would write that as negative 3 over c squared. So notice here, this was a negative, so I just moved it into the denominator. Okay, so remember this problem, because when we get to D, so we're on B right now, when we get to D, we're going to see something a little bit different here, because remember I said that only C was being raised to the negative second power. But when we get to D, you're going to see that it's a little bit different there, and it's because there's parentheses involved, and we're going to see that after we do, you know what, let's jump to D right now, actually. Let's, instead of doing this in order, let's go to D right now. So notice the difference between B and C. The main difference is the parentheses. And you can see that there's parentheses around both the 3 and the x. And since it's being raised to the negative second power, that means that both the 3 and the x are being raised to the negative second power. So that applies to both of them. Whereas in B, they did not have parentheses, so that negative 2 only applies to the thing it's attached to, which was the c. So in this case, I see 3x is being raised to the negative second power, which means that I need to put this in the denominator. When I put it in the denominator, it still stays as a 2, it's just not negative. And it's still in parentheses. So what we've got there is 1 over 3x, that whole thing there being raised to the second power. Now really what happens there, we've learned, is that when it's to the second power, is both the 3 gets raised to the second power and the x gets raised to the second power. Basically, that's how it works. That 2 applies to the 3 and it applies to the x. So when we work that out, we get 1 over, well, 3 squared is 9, and x squared is just x squared. We get 1 over 9x squared. So that's the difference between C and D. Again, the parentheses means that that exponent applies to every single thing that's in there. It went to the negative 3. It also went to the x. So I just moved everything into the denominator. Whereas in the first one, I only moved the c into the denominator because it was only attached to the c. All right, moving on to C. Now we've got 3 separate things. 1, 2, 3. So the first one is a 2 being raised to the negative first power. So what that tells me there is that this should look something like this. It should look like a 2 that is in the denominator to the first power. Why? Because it's still a 2 to the first power here, but it's a negative first power. And what the negative does is it tells me I'm on the wrong side of a fraction, so I'm going to move it to the denominator. So that, it becomes 1 over 2 to the first power, or just 1/2. A to the 0 power, well, anything to the 0 power is going to become 1. So we've got 1/2 times 1. And then b to the negative third power. Well, again, it's a negative, so that b is going to go in the denominator, raised to the third power. This becomes 1 over b to the third power. So multiplying by 1 isn't going to do much. Like if we have 1/2 times 1, that is just going to become 1/2. And then we multiply that times 1 over b to the third power. Now remember, when you multiply fractions, you just go straight across the top. 1 times 1 is 1. And in the bottom, we get 2 times b cubed, which is 2b cubed. All right, so we already did D, so we're going to move down just a little bit here to A in the next section. And it says they want us to write these in simplest form without 0 or negative exponent. So we're not going to write anything with a 0 exponent or a negative exponent. We're going to change them so they don't have those anymore. So let's look at the first one. We've got 10 to the negative second power times 10 to the negative third power. Remember, when you've got two things that you're multiplying that have the same base, like 10 to the negative second power times 10 to the negative third power, you're going to add their exponents. Again, same thing we've always done with x's, with everything else. We're just adding their exponents when we multiply, which then becomes 10, oops, that's not a 10, 10 to the negative fifth power. Now, they told me in the instructions not to write it with a negative exponent, but I have a negative exponent. So what I need to do now is I need to change this. I'm going to change this 10 to the negative fifth power, and when I do, I'm just going to write it with it in the denominator as 10 to the fifth power, 1 over 10 to the fifth power. which would be done, except for we know how to do 10 to the 5th power. Now you can sit there and do 10 times 10 times 10 times 10 times 10 if you want to keep doing it over and over again. But really what this means is that when you have 10 being raised to an exponent, that what we're going to get is we are going to have a 1 followed by 5 zeros. So 1, 2, 3, 4, 5. This is 1 over 100,000, or 1/100,000th. So all we did there is we started by multiplying these two things together. Since they have the same base, we added their exponents. -2 plus -3 was a -5. And then from there, 10 to the -5th power means that goes in the denominator, and we would then write it without the negative. We lose the negative once it's been moved to the other side of a fraction. And now we've got 1 over 10 to the 5th power there. Then from there, all we needed to do was simplify the 10 to the 5th power, which became 100,000. Okay, so we see parentheses here. That's a key thing to look out for. So we've got parentheses. That means that this -2, this exponent out here, is going to go both to the -3 and to this 5 to the -1st power. So let's start with this. We've got a -3 that's being raised to the 2nd power. And then we've got a 5 to the -1st power that is then being raised to the -2nd power. Well, let's take a look. Right there, we've got -3 to the -2nd power. So what that's going to look like is this. 1 over 3, -3 to the 2nd power. So what we're looking at there is 1 over -3 to the 2nd power. -3 times -3 is a positive 9. Negative times a negative is a positive. 3 times 3 is 9. Now what we've got here is a 5 to the -1st power being raised to the -2nd power. What's great about this is when we have an exponent that is being raised to another exponent, it's really super easy to deal with. We can deal with this the long way, and I'll show you that in a minute, but let me show you the easy way. What you can do when you have an exponent being raised to another exponent is just multiply those two exponents together. So -2 times -1 would be a positive 2. Negative times a negative is a positive, and 1 times 2 is 2. So what we get there is this part is actually just going to equal 25. So we end up with 1/9 times 25 over 1. When we multiply that, we get 25 over 9. Now, you could have made this way more complicated. You didn't have to do it that way. You could have done it really complicated. You could have said this is 5 to the -1st power, which is the same thing as 1 over 5 to the 1st power, right? And then what we're going to do is take that 5 to the 1st power and raise it to the -2nd power. So this is the longer way. I don't recommend this way. This takes much longer. And then in which case we had 1 over, well, 5 to the 1st power is 5, and then we're raising that to the -2nd power. Well, now we've got a -2nd power in the denominator, and what I told you is that if that's in the denominator, it just means it's on the wrong side of a fraction. So we're going to rewrite that as 5 to the 2nd power, which equals 25. Now, I don't recommend that way. If that seemed confusing to you, I think it is a lot longer to do. I would stick with this way right here, is that when you have an exponent, and you are raising that exponent to another exponent on the outside, just multiply them together. -1 times -2 is a positive 2, and 5 times 5 is 25. So here we've got a monomial, and this is a little bit different than yesterday, so when we did this before. So there's a lot of things going on there. There's a 3 to the 0 power, there's a 2 on the bottom, there's some x's, and there's some y's. Now, you might try to pull out a common factor and cancel them out, but then what we get is this really weird thing because we're dealing with negative numbers there, and so, like, what would we have left over? So I like to deal with them in parts here. So first of all, one of the first things I see is that 3 to the 0 power. Like, I'm going to rewrite that because anything to the 0 power, as long as it's not 0, will always give me 1. So that's this right here. This 3 to the 0 power just becomes 1. And then On the bottom, we've got a 2. On the top, we've got an x to the negative third power. On the bottom, we've got an x to the negative first power. We've got y on top and y to the negative second power. Now, we could try to factor something out, but it gets a little bit weird. Like, what do you factor out? Do you factor out an x minus 1? Do you factor out an x minus 3? Like, it's hard to figure out what to divide by. So an easy way to deal with this is that 1 and that 2, well, they can't be simplified. That's there. They're not going anywhere because they can't be simplified anymore. But the x's and the y's look like they can be simplified. So if we look at the x's, we've got x to the negative third power divided by x to the negative first power. Now remember, I told you that when we divide two things with the same base, it's the same thing as subtracting their exponents. So if I wanted to rewrite this, it would be x to the negative 3 minus negative 1. Remember, because I'm dividing, that means I'm subtracting their exponents. Well, negative 3 minus negative 1, those become a plus. This becomes x to the negative 2. So x to the negative 2 there, that means that's going to go into the bottom, right? That's going to go into the bottom of this as an x squared. Because remember, if this ends up as x to the negative second power, that means that this is going to definitely go into the denominator, and it's going to go in as an x squared. I'm going to do the same thing with the y's. Y divided by y to the negative second power is the same thing as y to the first minus 2. Minus negative 2, excuse me. So we've got 1 minus a negative 2. This becomes y to the third power. Now notice this is not a negative exponent. It is a positive number, so we're going to leave it in the numerator. So we get y to the third power. Well, 1 times y to the third power is just y to the third power. And in the bottom, we get 2x squared. All right, so next up here, we're just going to do a little bit of moving around here. So I see that I've got an 8 to the negative second power. So really what that should be is that means that that 8 is on the wrong side of a fraction. So I'm going to move it to the right side of a fraction. 8 to the negative second power would just be an 8 to the second power in the denominator. And this 2 to the negative third power means it's on the wrong side of a fraction because it's got a negative exponent as well. So I'm going to write that as 2 to the third power on the other side of a fraction. Notice it was on the bottom and it was negative, so since it was negative, I just moved it to the top. This 8 to the negative second power was negative and it was on top, so I just moved it to the bottom, and then it makes all the exponents positive. The b to the third power doesn't need to be moved because it's not a negative exponent. However, this a to the negative fourth power, that's on the wrong side right there. So I'm just going to move it up top. A to the fourth power. This b to the second power down here is not a negative exponent, so it does not get moved. It stays exactly where it is as a b to the second power. So now everything's on the right side. If you notice, there's no more negative exponents. Everything's been moved. If it had a negative, it switched sides of the fraction. So here we go. On the top, we've got 2 times 2 times 2, which is 8. On the bottom, we've got 8 times 8, which is 64. On the top, we've got b to the third power. On the bottom, we've got b to the second power. So right there, we can say b to the third power divided by b to the second power is the same thing as b to the 3 minus 2, which is b to the first power, or just a b on top. And then that a to the fourth has nothing to cancel with, but it's more proper to write it with the a first and the b second. So I'm going to do a little changes here. That 8 over 64, first of all, 8 and 64 have a common factor. They can be reduced. 8 goes into 8 once, and 8 goes into 64. It goes into 64 8 times. So that becomes 1/8. There is nothing left in the denominator, but there is an a to the fourth power in the numerator, and there is a b in the numerator. So just to clean this up a little, here's what this would look like. a to the 4th power, b, on top, and 8 in the denominator. All right, next up, write in simplest form without 0 or negative exponents. So right there, notice the parentheses. That -3 goes to the top and it goes to the bottom. So here's what I'm going to do is I'm going to rewrite this. That's 2 to the -3rd over 3 to the -3rd. It means it goes to both. But notice they both have negative exponents, which means both of them are on the wrong side of these fractions. So I'm just going to fix it. 3 to the 3rd power now goes on top, and 2 to the 3rd power now goes on bottom. Why? Because they were both negative exponents. So I just moved them to the other side, and it loses that negative exponent. Now we're going to rewrite this. So we've got 3 times 3 times 3, which would be 27, and 2 times 2 times 2, which is 8. Just becomes 27 over 8. Okay, for this one, that -1 there up here gets applied to both the top and bottom. Why? Because it's all in the parentheses. So we get 2x to the -2nd power. That is being raised to the -1st power. And down here we've got 5y to the 3rd power, and that is being raised to the -1st power. So notice here's an exponent being raised to an exponent. So one of the things that we said that we can do is multiply these two things together. But when we multiply them together, here's what's interesting about that. We can multiply this -1 times the -2, and we would get a positive 2. So that would be what the x is going to give me. That x would now have an exponent of a positive 2, because -2 times -1 would be a positive 2. But that -1 also needs to apply to this 2. So we would get 2 to the -1st power. Notice that -2 there was not attached to the 2. It was only attached to the x. But this -1 on the outside, that needed to go to both things on the inside. So it attached to the 2. And when we multiplied this exponent and this exponent together, we got a positive 2. Now on the bottom, we're going to do the same thing. So we're going to multiply this times this, and we get y to the -3rd. And -1 will also be attached to the 5. So anything that we've got here that has a negative exponent is on the wrong side. So I'm going to correct all of that. Anything with the negative exponents is about to change sides. So let's start with that 2. That 2 is going to move to the bottom as a 2 to the 1st power. Now I could write 2 to the 1st power, but that's just 2. That x squared up there is not going to be moving anywhere. It's just an x squared because it has a positive exponent. So it does not need to move. So this guy's done. That guy's done. 5 to the -1st power in the bottom, well, that does have a negative exponent, so that's going to move to the top. That's 5 to the 1st power. And that y to the -3rd power, that's on the wrong side as well. That needs to move to the top. So here's where we end up after all of that. We always write our numbers first. So 5 to the 1st power is 5. X squared, y cubed, all over 2. So all that's happening here is making sure we apply the exponents to everything that we need to. And anytime you see a negative exponent, it's on the wrong side of a fraction. All right, we'll try to move this along here. We only have a few more here. Okay, again, that -2 is going to apply to the top and bottom and everything in there. So when we're talking about the top, this -2 is going to go to the 5. So that's going to become 5 to the -2nd power. This -2 is going to be multiplied with that positive 5 there, and we're going to end up with an x to the -10th power. This -2 is going to be multiplied times that 3, and we're going to get y to the -6th power. 3 times -2 is -6. but also that negative 2 is going to be multiplying with everything on the bottom. So that 6 is going to get a negative 2 as an exponent. And that y squared, well, remember, we're going to take this times that becomes y to the negative 4th. Everything that has a negative exponent there is on the wrong side. We're going to move it. So let's start with that 5. The 5 is going to go to the bottom as a 5 squared. The 6 is going to go to the top as a 6 squared. The x to the negative 10th is going to go to the bottom as an x to the 10th. Notice we're just dropping the negatives when we move them to the other side. That y to the negative 4th is going to move to the top as a y to the 4th. And the y to the negative 6 that's on top is going to move to the bottom as a y to the 6th. Now, are we done? Not even close, because there's a bunch of things to do. First of all, 6 squared is 36. On the bottom, 5 squared is 25. We've got an x to the 10th power on the bottom. Well, that can't really cancel out with anything. There's no x's on the top. However, there is a y to the 4th power and a y to the 6th power. So remember, when we divide these, that's y to the 4th divided by y to the 6th, which becomes y to the 4 minus 6, which is y to the negative 2nd. Which means that we're going to have two of these y's that we're dealing with are going to end up being in the denominator. So what we've got here is that these are going to end up as y to the negative 2nd, or just 2 y's in the denominator. So 36 on top, 25 on bottom. There's an x to the 10th power. There's a y to the 2nd power. That's it. So there's a lot of things to be comparing here. All right, one more in this area, and actually we're almost finished now. So again, this negative 1 applies to both the top and the bottom. It is going to be distributed here. It's going to be distributed here, and to both the things on the bottom. So what we've got is that negative 1 is going to be multiplied with this positive 2, and this is going to become 4 to the negative 2nd power. That negative 1 is also going to apply to the x. In the denominator, that negative 1 is going to be multiplied with the 3, so we get 3 to the negative 3rd power. And that negative 1 is going to be multiplied with the 2, and we're going to have y to the negative 2nd power. Now check it out. There's all those things there, and we're going to move everything that has a negative exponent. So that 4 to the negative 2nd power becomes 4 to the 2nd power down here. That 3 to the negative 3rd power becomes 3 to the 3rd power up here. X to the negative 1st power on top becomes x to the 1st power on bottom. Y to the negative 2nd on bottom becomes y to the 2nd on top. Any math I can do here? Sure. 3 to the 3rd power is 27. Y squared. On the bottom, 4 times 4 is 16 x. The only other thing I'm looking at this point is, are there any common factors? Well, there's x's and y's. They're not going to be like anything I can divide with each other. 27 has factors of 1 and 27, 3 and 9. It doesn't look like 16 has a common factor with them, so this is going to be where we're leaving off. All right. We have 4 more, and these are pretty quick. Write without using fractions. Well, what makes this a fraction is what is in the bottom. So if these things weren't on the bottom, then we could say, oh, okay, then I don't write this as a fraction anymore. So one of the things that I could do is I could take what's on the bottom and represent it with a negative exponent. So I have a couple ways of doing this. It says write without using fractions. I could either write this as 3, because that 3 up there is just a 3 to the 1st power, times 10,000 to the negative 1st power, meaning that 10,000, where it really should be, is in the denominator. But they said don't write it as a fraction, so I can rewrite it as 10,000 to the negative 1st power. Or if I wanted to, I could call that 10, sorry, I hit the wrong button there, 10 to the negative fourth power. If you think about it, 10,000 can be written as 10 to the fourth power, but I need that 10,000 to be in the denominator. That's where it really should be, but they said write it without using fractions. So the best way that I could write it like this, as 3 times 10,000 to the negative first power, but a much cleaner way of looking at that is 3 times 10 to the negative fourth power. So 3 times 10 to the negative fourth power, that 10 to the negative fourth power just means 10,000 that would be in the denominator. So here, that 5x squared, it's pretty safe. It's 5x squared times something. And that something means that the y has to be in the y needs to be moved to the other side. So to move y to the other side, it's a y to the first power. I'm just going to call it y to the negative first power. That moves it from the denominator back up to the numerator. And z to the third power, I can rewrite as z to the negative third power. That's what it does, is it takes it out of the denominator, moves it to the numerator. So when you change something from a positive to a negative exponent, it moves it to the other side of the denominator. That's all there is to it. I only needed to move this. I didn't need to move the top. The top isn't really what makes it a fraction. That's just a 5x squared. But that yz to the third power in the denominator, that's what's making it a fraction. So I needed to take that y and move it to the other side. To do that, it needs a negative exponent. That z to the third, to move it to the other side, I needed to make it a negative third to go to the other side. 2 more. All right, so we've got 1,000 divided by x to the 7th power. Again, this is the problem. The thing that's in the denominator is what's causing us issues. So we could rewrite this in a couple ways. We could rewrite this as 1,000 times x to the negative 7th, meaning I want to take that x to the 7th and I have to move it out of the denominator. That's the only way I'm going to make this so it's not a fraction if it's not written in the denominator. But really a much cleaner way of doing this is let's write 1,000 as 10 to the third power times x to the negative 7th power. Just a nice clean way of writing that. When we talk about powers of 10, it's very easy to write them. Instead of writing 1,000, we could write 10 to the third power. Last but not least, that 5x to the fourth y cubed in the numerator, that's safe. It's not part of the problem. When I say the problem, it is part of the math problem, but it's not part of our issue. The issue comes in the things in the bottom. I need that w moved to the top. So what I'm going to do is say w to the negative second power, because that 2, I need it moved to the other side there. And that z to the fifth, I need it moved to the other side. So z to the negative fifth. That's all there is to it. Nice and easy. Find the ones that are causing you problems, add negatives to move them over to the other side. That's it. So we will be going over this when I return back tomorrow, but in the meantime, this will get you through the lesson.